are the transport layer. Don't forget, all these things we've been discussing for like a week plus now. It's about the flow of data. We've been talking about the flow of data. And I told you the journey will start from application layer if you are the sender, and which is always the case most of the time. But for some reason, the way they arrange the curriculum, they started from physical layer. So we're discussing all of those things, the things that happen at physical layer, things that happen at data link layer, things that happen at network layer. So today's class, we want to talk about transport layer. What are the things that happen at transport layer? So anytime you hear transport layer, what comes to your mind? Those are the things we want to talk about. And of course, you remember from our OSI model, transport layer is layer 4. Transport layer is layer 4. So what are the things that happens at transport layer? The main job of transport layer is for transportation of data. That's the main job of transport layer, to transport data from source to destination. I made mention of that briefly in the last class. Now we are in here today now. IP shows the road. Transport layer takes the message to some source to destination. IP shows the road this way to London, this way to France, this way to America, this way to Australia. Transport layer is engaged, is in charge of moving the message from source to destination, transportation of data. So we are going to say a lot about transport layer. Yeah, I can see one tortoise already. Oh. It's too early to start seeing tortoise. Class rep, can you hear me? Mr. Uche, can you hear me? Maybe it's not from my hand. We just have to endure. This network these days has not been good at all. Network has been crazy these days. So the person sending me tortoise, others are sending me thumbs up. That means it's from your hand. So what you guys need to do for me, Mr. Huche, Lucy, and the rest, once you see somebody sending tortoise and you know that you are good from your own hand, just give me thumbs up immediately so I will not have to talk about that. So if you give me tortoise and others are giving me thumbs up, you know that the problem is from your own hand. So I will not just bother talking about that. So you guys need to help me with that. Thank you. So what's the role of transport layer? I told you transport layer basically is to move the message from source to destination. It is in charge of anything transportation. And don't forget, these things happen end to end, end to end. When I say end to end, concurrently from the sender and then from the receiver, all the layers, both layers at both end, transport layer at the source, transport layer at the destination, they are working together end to end. So don't forget that. This transport layer moves data between applications on devices in the network. So when you send your message, the main layer that is responsible for transporting the data is your transport layer. So what do we call layer at transport? Data at transport layer. Don't forget in our class, one of the classes I told you, you call it segment. So in today's class, we are going to talk about segment. We're not going to break it down. We're going to dissect segments, which is what happens at, or what we call your data at transport layer. So first thing first, the transport layer moves the data between application on devices from source to destination. And of course, whether you are talking about OSI model or you are talking about TCP IP model, transport layer is transport layer under the two models. Take note of that. So these are the summary of what transport layer will do. Summary, then I will begin to expand them. Transport layer has the following responsibility. Number one, tracking individual conversations. Transport layer tracks individual conversation. Segmenting data and reassembling segments is the job of transport layer. It has other information. Of course, other layers also will do that too, depending on what they do at their layer. Transport layer also do that. Identify, separate, and manage multiple conversation. That's another job of transport layer. It uses segmentation and multiplexing to enable different conversation to be interleaved on the same network. It's another job of transport layer. All of these things we have just mentioned now. That is a summary about all the things that transport layer is going to do. And let's now begin to break these things down or demystify them one after the other. Transport layer. If I can't find it, I will just have to. and then to you myself. If I will meet them at the front, then I think they should be at the front somewhere. Maybe I'll leave them. No, no, no. Let me just explain them to you guys. If we meet them, then I will leave them alone. So when they say transport layer tracks individual conversation, you know, end to end, there are things happening from end to end. Let me first of all talk about it. One of the things that will happen is segmentation of the data. So one of the things that will happen is sequencing. What is segmentation of the data? I think I've mentioned this in this class. If I want to eat food right now, I cannot eat the food at a go. The food has to come spoon by spoon into my mouth. So when you want to send a message from source to destination, because the message cannot travel as at once. Yes, I'm recording. Thank you, Mr. Wahab. Because the message cannot travel at once, the message has to be broken down into pieces. Let's say into 4 segments, for instance. Now, all the message, it has to be broken into segments. And when it is broken into segments, those segments have to be labeled. Let's say segment 1, segment 2, segment 3, segment 4, and so on and so forth. And they will now travel. Of course, those segments will be converted to zeros and ones later. You know all of those things. They will now travel across the wire. By the time they get to destination and we want to arrange them, they will come, they may get to destination out of order. Meaning maybe 3 will get there first, 4 will get there later, next, 2 will get there next. So the destination device will use this numbering or labeling to arrange them. Put the first one first, another one, another one, another one, and then open them up and then assemble them together. This is part of the job of transport layer. Transport layer is in charge of segmentation. It's in charge of sequencing, that is like numbering or labeling. It's in charge of hiding header information, guys. This information here is related to what is in this place, and I'm going to talk about that now. What kind of information is hidden at layer 4? You remember, guys, don't forget this. Don't ever forget this. At layer 2, source MAC address, destination MAC address is added to our header. And that is what we call frame header. Frame header. At layer 3, source IP address, destination IP address is added to our data. That is another header. And that one is called packet header, or some people call it IP header. That is what happens at layer 3. Now we're at layer 4 right now. Another information will be added. Do you know what is added at layer 4? It is called source port number and destination port number. I have a lot to say about this in today's class. Source port number and destination port number. This is added at layer 4. And the header there, some people will first of all refer to it as segment header, which is not wrong. But down the road, we can break this segment header into 2. That header could either be TCP header or UDP header. You will find out why as we continue. So when we say segment header, what is in the segment header? Source port number, destination port number. Source port number, destination port number. This is a layer 4 issue. This one here is a layer 3 issue. This one here is a layer 2 issue, or this issue, yeah, concept. So what is the big deal about this port number? Let me tell you briefly. Port number. Port number points to the services you are requesting for. Port numbers point to the services you are requesting for. E.g., HTTP, which is, you people know HTTP very well, is port 80. HTTPS is port 443. FTP is port 21. SMTP is port 25. DNS is port 53. Guys, all of these things that I mentioned right now, these are protocols. They are all called application layer protocols. These are protocols that governs what you do on the internet, one way or the other, or let me say on your computer. E.g., when you are sending mail or you are receiving mail, the protocol that governs sending and receiving of email majorly is simple mail transfer protocol. And there is a number called port number attached to that service, attached to that protocol. So when you are browsing the internet and you are downloading, the protocol at that point in time that is you're engaging is FTP, and that protocol has a port number. Automatically, you don't have to do anything. These things are just there, and it is called port 21. So this is the idea. If I am requesting for a service from a server, and that server can give me HTTP service or HTTPS, which is the secured one, the server can give me FTP service, the server can give him SMTP service, and then all of these things, they run on different port numbers. And a server can give me all of these services. How will the server know the request I'm asking for, the service I'm asking for, if there is no destination port number? It's like you enter a restaurant, you just start answering, talking there, give me food, give me food, give me food. They drop the menu in front of you. There is fried rice, Chinese fried rice, coconut fried rice, jollof, eba, amala. You say, just give me food. No, you cannot just say, just give me food. You have to indicate what you want to eat. That is the essence of port numbers. Destination port numbers is to tell the server the kind of service you are requesting for, and all of these things are standardized. So where do we get involved in the long run? In the long run, we can get involved, make use of these port numbers. For instance, I don't want people to browse on my network between a particular period. I can block port 443. I just tell my router, when you see any destination port number 443, block it. Maybe between 12 to, let's say 8 to 12, and then 1 to 4. From 12 to 1, open that port. The port numbers are services. Or I can say, no, I don't want somebody to be able to download on my network. Between maybe on Monday, it's a busy day for us. We need the network to be up and running. You block port 21. Nobody will be able to download. See how you are making use of that service. So when the router sees people trying to make place demand on port 21, the router will block them. Or if you want to do cyber security down the road, you begin to see some things going on your network and you don't understand what they are. You look at the port number. If it is not a popular port number or a public port number, you get that port number out. You go to some website that are cybersecurity sites. You drop it there. They will tell you the service that thing runs on. There is no service that runs anywhere in the world that does not have a port number. No service. If I want to see whether your system is vulnerable right now, if I'm teaching cybersecurity, I can run some software on your system and I begin to see some ports that are running, some ports that are open. Once I see the ports that are open, I know that these are the services that are running on your machine. And then I can find out which of these ports is vulnerable, meaning which of these services is vulnerable. So we do a lot of things with port numbers, guys. We do a lot of things with port numbers. And I'm going to show you some things before we finish the class today. That's also just a digression. I need to explain that to you. So this port number thing we're talking about, it is layer 4 that takes care of that. That is what is added to our message. Source port number and destination port number. Source port number, we don't even bloody care what is in that source port number. It is dynamically generated. You see the range as we proceed. But destination port number must point to the service you are requesting for and must be a specific service. And that is always in the message. It's like you are traveling out now. If I grab your passport, I look at your visa, I know the country you are going into. That's port number for us. Destination port number is to tell the service that you are requesting for. If it is not a public number, port number that is popular, I can do research on it to see the service that that port runs on. These are things you need to understand. Transport layer does that for us. I'm going to show you guys some things before we finish. It identifies, separate, and manage multiple conversations. Transport layer is the one doing that. How? I will launch my Firefox now. I'm on Facebook. I'm on Yahoo. I'm on Amazon. I'm on, let's say, Instagram. I am on CNN. The same computer. How will the computer keep tracks between me and Facebook? The conversation between me and Facebook, conversation between me and Yahoo, conversation between me and Amazon, conversation between me and CNN. It will generate different source port number, different source port number, different source port number, different source port number to different destination. The destination port number may be the same because they are all running on HTTPS at that level, maybe port 443, 443, 443, but you are going to see that the source port number will be the same for different websites. And I'm running just one browser. Because if the computer does not have different source port numbers, it will be difficult to keep track of the conversation between me and a particular website. So in order for us to have, let's say, separate or different conversation, there is a port number, source port number, destination port number attached to different website. The destination port number may be the same because all these websites, HTTPS, that's the protocol they run on, but my source port number will be different, and it is the transport layer that takes care of this. So it enables multiple conversations, separate, manage multiple conversations between me and the outside world. So with that, I don't have a problem. The computer keeps tracks for me. It helps me to have that connection. Because for every connection, there must be a what we call a socket. For every connection, that must be what we call a socket. What is a socket? Combination of my IP address, the port number, source port number, source IP address, destination port number, destination IP address. That creates a socket. And so when I'm going to a website, there must be a socket established. It's like a virtual link between me and that website. And transport layer is the one doing this job for us. Don't forget, we call our data segment a transport layer. And these are some of the things going on here. I'm just expanding it gradually. Let's proceed. So this is where I'm going to, guys, here now. Every layer we have been talking about, there are protocols that are very important at those layers. For instance, when we talk about data link layer and physical layer, they've combined them here together now because this is all about TCP/IP. This is all about TCP/IP now. This is all about TCP/IP. The most important protocol at data link layer is Ethernet. I talked about that in one of the classes, Ethernet. But you know what? When you come to layer 3 of the OSI model, which is network layer, and it's the same thing as internet layer of TCP/IP, guys, the most important protocol here at layer 3 is IP. So what I'm trying to say in essence is this. At layer 2, there are protocols that operate at layer 2. At layer 3, there are protocols that operate at layer 3. At layer 4, there are protocols that operate at layer 4. And at layer 7, which is the application layer, there are protocols that operate at those layers. So when we talk about layer 2, layer 3, layer 4, layer 7, we are trying to, even though we have discussed or we are mentioning things that happens at that layer, we also need to know about the protocols that operate at those layers. E.g., I've talked to you guys about IP. IP is a layer 3 thing. It's an internet layer protocol. It's a network layer protocol. There are others like ICMP. We have a chapter on ICMP. I'm going to demonstrate that. It's also a layer 3 protocol. So the most important protocol at layer 3 is IP. It's the most important protocol. ICMP is also important, but we can do without it. Even though it's difficult, we use it to test connectivity. But IP, if IP address is not in place, you ain't going nowhere. Then look at it here. This transport layer we're talking about today in today's class, there are 2 protocols at that transport layer. So we call them transport layer protocols. They are TCP and it's UDP. TCP and UDP. So what is the big deal about this TCP and UDP? What we are simply trying to tell you is this transport layer that moves message from source to destination, it does this in 2 different ways. It can use TCP to carry out the assignment, or it can use the UDP to carry out the assignment. That depends on the application layer protocol is working with or is trying to move from source to destination. Ha! I hope I've not lost some people. What do you mean by that? You know, the journey always starts from the application layer. So let's assume that you are dealing with a protocol that runs on top of UDP. For instance, now, this is another application layer protocol. That's when we move things out of our router into a server, TFTP server, or from that server into the router. This is the protocol that governs that. And that protocol runs on top of UDP. So you know what? If transport layer is going to do anything on this TFTP, it will use UDP to get the job done. But there are other protocols that run on top of TCP, like FTP, HTTP, SMTP, DNS, HTTPS. That is secured HTTP, even Telnet. These are protocols we're going to be talking more about as we proceed. All of these guys run on top of TCP. So what a big deal. What's the difference? Any protocol that runs on top of TCP needs what we call acknowledgement, sequencing. Acknowledgement. What is the big deal about TCP? TCP is just like I'm sending $1,000 to Uchi, and I've sent the money. When he gets the money, he's going to give me a call and say, thanks, I got the money. That's TCP. That's an acknowledgement. But if I'm using UDP, if it is a protocol, application layer protocol that runs on top of UDP to send the money, if it's TCP now, for instance, TFTP rather, it uses UDP, and I send money to Uchi, $1,000, and he got the money, Uche will not bother to call me back to tell me that he got the money. There is no acknowledgement. There are some protocols that does not need acknowledgement. That's the way they are designed. There are some protocol that needs acknowledgement. So TCP we either use transport layer rather, we either use the TCP to get the job done, to move data from source to destination, or use UDP to move data from source to destination. It depends on the application layer protocol is working with or is trying to help to get to move the data to destination. I hope I'm communicating. So TCP needs acknowledgement. That's not the only thing. You're going to see other things as we proceed. UDP does not need acknowledgement. So that is why I said, when you talk about transport layer, you talk about segment header. So what do you talk about when you talk about segment header? And I said, but it can be TCP header or UDP header. That is because transport layer may decide to use UDP based on the application layer protocol or decide to use UDP. So it depends on what the protocol is built on. If it's a protocol that is built on UDP, there's nothing transport layer can do. It has to use UDP. And some of the protocols, they run on both. Some protocols run on both UDP and TCP. Look at DNS. And if you guys don't know DNS, I tell people, computers do not talk in our language. They don't use our language to talk. What do I mean by that? When you want to go to Facebook now, you say you go to your website, what do you call it, browser. You say www.facebook.com. Computer doesn't know what is Facebook. They don't use name to talk. Computer use IP address to talk. So we need something that will convert this name, domain name, to an IP address, maybe 200.100 or something or something. I'm going to show you before we finish into this class. That is the reason for this DNS. So it is easier for humans to cram names of websites than cramming the IP addresses. That's why they gave us name. But then behind the scene, they built a system that helps us to convert these domain names to IP addresses. Without this DNS, you cannot go to those websites. If the DNS server is down, those websites will not be reachable, even though they are available. They are available. So computer do not use. In fact, let me demonstrate something to you guys. Sharp, sharp. I'm going to go to my browser right now. I'm going to go to my browser. No, sorry, command line. I'm going to teach you guys how to get to all this command line and all of that with time. Uh, Command line. That is for people that don't know how to get there. This is where we do a lot of stuff here. I'm going to show you guys. So let me put in a command. ns lookup google.com. I just want to get Google IP addresses, one of Google IP addresses. Look at what I got in this place now. If you guys write this address down right now, that is one of Google's IP address, IP version 4. I could have picked IP version 6, but I don't want to complicate issue for you guys. So if I copy this address out right now, 142.250.203.238. If you put this in your browser right now, you'll see that you are going to be in Google. Let's test it. I'm already in Google, so let me get out of Google. Let me go to cnn.com. So you see that I'm going to get out of Google. I'm in CNN right now, so you know that I've left Google environment. So now I want to copy that IP address I got out right now and put it here. So I'm going to say 142.250.203.238. Look at the IP address. If I put this IP address right now, that's Google's IP address. I'll hit enter right now. It's going to take us to Google. Can you guys see that we're in Google? You can take it from your own hand too, so that you don't say this guy is doing abracadabra. Let me do something again. Let me get CNN's some of the IP addresses. They will have more than one. CNN.com. NS lookup CNN.com. Oh, they won't allow me to get this IP address. Yes, I got some. Look at some here. 151.101.3.5. They have plenty. They have more than one. So let's go back to this place. Put 151.101.3.3.5. That's one of CNN. Some websites don't allow you to use that. They block it. So if CNN has blocked it, there's nothing we can do. Let me see another site. I may accept that. I think. Let me try Facebook. So I'm trying to prove a point to you guys. Facebook.com. One 102.132.101.35. Let me try this. This is supposed to be Facebook. One of Facebook IP addresses. .250. Am I correct? Let me check again. 102. Okay, so I'm making this 101. Sorry. 101.132.101.35. So if that IP address is not blocked, you're going to see that I will be in Facebook now. I think Facebook too beginning to accept the rules and continue. This should take me to Facebook. So some websites don't allow you to come with IP address because they know that you are not supposed to come with IP address. You're supposed to come with domain name. I think Facebook too blocked that. So I'm sure of Google. No. I'm sure of Google and few other websites. No, this one is not taking me to Facebook. It's not supposed to take me to a different site. Did I get this correct? Let me check again. 102.135.101.35. Oh, I put 101. Sorry, it should be 102. I was wondering now. It should be 102. Let me edit it. 102. Yeah. You see? It's giving me a Facebook logo. And then here am I on Facebook, guys. You can see my Facebook here. So that is what I want you guys to understand. So computers don't talk with names. They talk with IP addresses. The only reason why it is working is because of this protocol here, DNS. Take note of that. Thank you, Mr. Uchi. So we have all these protocols here. They are called application layer protocols. These are the popular ones. And they will either work on top of TCP, thank you, class rep, or UDP. And all of them, either you are running on TCP or UDP, there must be IP. And when you have IP, you must have IP. You must work on one of LAN protocol or LAN technology, which we call Ethernet. So take note of that. So when you say TCP header, UDP header, it simply means the protocol we are referring to at that point in time is using TCP. And what is that in the TCP header? Source port number, destination port number. What is in the UDP header? Source port number, destination port number. But look at the difference. The acknowledgement I spoke about. Let me show you. I come back here. Let me show you something. Okay, yes. Let me just show you. Look at this header here. This is our TCP header. TCP header. What's the big deal about this TCP header? Look at this TCP header. There is source port number, destination port number, sequence number, acknowledgement number. Take note of source port number, destination port number, sequence number, acknowledgement number. Let's take a look at the UDP one. UDP, where are you? You see the difference now. It's like this. Okay, I think I overpressed this. No. Okay, yeah, this is UDP. Now take a look at UDP here right now. Source port number, destination port number, there is no sequence number, there is no acknowledgement. That is TCP for you. I sent $1 million to class rep. She got it, she won't acknowledge it. I sent $100,000 to Mr. Uchi. He got it, he acknowledged. So the main difference between TCP header and UDP header is this acknowledgement thing. That's what I want you to take note there. So there are some applications that use TCP. There are some applications that use UDP. That is just the bread and butter of transport layer. You need to take note of that. Some applications use UDP, some applications use UDP. So if it is an application that is using TCP, there is acknowledgement. If it is an application that is using UDP, no sequencing, no acknowledgement. But the source and destination port number must always take place. This happens at transport layer. And as a result, okay, so what's the big deal about the acknowledgement? The main reason for acknowledgement is because of reliability. That's why we tell you TCP is reliable, UDP is unreliable. Because if I send $1 million to class rep and she did not acknowledge it, and that protocol is using TCP, do you know what I'm going to do? I will send another $1 million. If it's using TCP. If she still doesn't acknowledge, I will send another $1 million. That is the way TCP behaves. I will keep on sending $1 million. I'm sending $1 million, $1 million. She didn't give me thumbs up. She didn't say, hey, man. I will keep on sending the money until she acknowledges that thing. But if it is UDP, I send you $1 million the first time. I don't need your acknowledgement. I hope you people can hear me. Please, if you can hear me, give me thumbs up. My website is the WebEx is showing me that there is connection issue. Okay, thank you. So that is just the way TCP operates. So I'm going to blast through now. I'm going to blast through, okay? So TCP provides reliability and flow control. So the flow control is okay. When you are segmenting is all about how much can you take at a time. We agreed on the size of data you can take at a time. Then I will be pushing it at what rate. That is the big deal about the flow control. So TCP provides reliability and provides flow control. So all of this issue of labeling, segmenting, tracking of segments, and all of that from source to destination is the job of TCP. TCP does that. Are we good, guys? Okay. Okay. So what about UDP? I've told you. UDP, they said is not reliable. And UDP, another way they refer to UDP, or what they say about UDP, they say UDP is a connection link protocol. It's like IP. It does not need end-to-end connection. Unlike TCP, TCP needs end-to-end connection. UDP doesn't. And UDP is a best effort delivery like IP. Send the message, rely on other protocols to help the job to make the message to get to destination. Like what? If there's any issue, UDP runs into trouble. It's going to depend on application layer protocol to help fix the problem, not TCP. And that is why somebody asked me that question in our last class when I talk about overhead. UDP has a little overhead. Why? Because it does not need to do acknowledgement. It does not need to segment data. It does not need to keep on going front and back. So there is no overhead. There's just a little overhead. Just small logistic, and that's it. We are good to go for UDP. So if any application is running on top of UDP, you know that that application does not really have serious problem when we don't come to overhead. It's not going to consume your bandwidth as such. And you're going to see some application that runs on top of UDP, e.g. voice over IP. If you guys have heard about voice over IP before, when you make phone call within our network, like intercom is not on the network. I'm just using that as an example. It's UDP. DNS runs on top of UDP. So any protocol, application layer protocol that needs low overhead, they will be designing on top of UDP. Any protocols that needs low overhead will be designed on top of UDP. Or let me say it will be designed to use UDP. Any application layer protocol that need to be very fast will be designed based on UDP. So UDP is fast, it has low overhead, does not require acknowledgement, does not resend lost data, deliver data as it arrives. What about TCP? I've showed you some of the protocols that run on top of TCP. TCP is reliable. These are the properties of TCP. It acknowledges data, it resends lost data, and it delivers data in sequence order. Not because it's going to deliver data in sequence order, but even if the data gets to destination out of order, TCP is going to arrange them back. That is the idea. So what is your takeaway here now, guys? At layer 4, my data becomes segments. What is the big deal at layer 4? Source port number and destination port number is added to my message. It now depends. If that protocol we're dealing with runs on TCP, we're going to have a TCP header. If that application layer protocol runs on top of UDP, we're going to have a UDP header. Not the two, it's one of the two. That's what happens at our transport layer. If I shut down this chapter again now, I've done justice to that chapter. But I still have things to talk about. I hope you guys can hear me. Please give me thumbs up if you can hear me. Okay, thank you guys. Thank you. So there are some repetition here. I'm just going to blast through. I won't waste time again. So TCP establishes a session. We have end-to-end connection between the source and destination. That is why it is connection oriented. It ensures reliably delivery. Why? Because of acknowledgement, segmentation, labeling, all of these things, or resending of data. TCP does that. It provides same order delivery. Even if data gets the destination out of order, it can rearrange it back. And TCP support flow control. It kind of helps us to manage the limited resources. At what rate do you want to take this thing? What size of segment can you take? It's like I'm feeding you. I have to ask you questions. What are the things you can take in? At what rate? At what speed? If I want to feed you now, you don't feed an adult, or let me say a 10-year-old person, maybe sick, the way you will feed a 2-year-old person. The speed will be different. The quantity of the food will be different. So you need to take note of that. And of course, I came here earlier. Look at our TCP header. So what do we have there? Source port number, destination port number, sequence number, acknowledge number. This is what makes it different from the UDP. Of course, look at where the real data is. That's the most important thing. Acknowledgement and sequencing. And here they talk about what is in our source port number. I've told you is what identified the source application by port number, which is dynamically generated. The most important one is the destination port number. That is the one that will talk about the data you are looking for. And it's a 16-bit field. Then sequence number is a 32-bit field. Used for what? Reassembling purposes, labeling of data, and the acknowledgement too. We have to see all the acknowledgement. I send the first segment, you acknowledge. I send the second segment, you acknowledge. The third segment, you acknowledge, and so on and so forth. Those are the most important part in the feed to me as far as I'm concerned. When we're teaching here, very important to us. These are what you have in your TCP header. The rest, you can read on those ones later. And look at this thing here. I like this particular slide. Application that use TCP. I've talked about them earlier. HTTP runs on top of TCP. HTTPS also runs on top of TCP because we don't use HTTP again. If you want to go to any website, especially for bank transaction or whatever, if you don't see the S there, please run away. You must see S. That is secure HTTP, and that is port 443. Runs on TCP. FTP runs on TCP. SMT runs on TCP. Are we together, guys? SMTP runs on TCP. SSH, that's another protocol we're going to talk about later, runs on top of TCP. All of these protocol runs on top of TCP. And of course, TCP will run on top of IP. Don't ever forget that. Don't ever forget that. Can you hear me, guys? Okay. I think I'm having a little challenge here. It's like my system is freezing. Just a minute. Can't find my pen again. Let's take 10 minutes break, please. Let me sort out this pro challenge. 10 minutes break. I will be back. 10 minutes. Okay. I think I'll send my this thing back.